So we're going to subtract x. We're going to add 2. And that will give me 0 equals x squared minus 4x. And the 2's cancel there. All right, so because of our reflexive property, we can move that over. X squared minus 4x equals 0. Doesn't really matter. So from there, okay, we want to factor to solve. What's our first step whenever we factor?
Greatest common factor.
Nice work. Greatest common factor. So what would be the GCF here?
2x.
X, good. You take out an x. That leaves us with x times x minus 4 equals 0. So now we have two factors. We have x and we have x minus 4. We'll set them both equal to 0. Well, x equals 0 is one of our x's. We need to add 4, and x equals 4 is our other x value in our points of intersection. Now to get the y value on the points of intersection, you want to plug those back in, okay? You can plug it back in to either the linear equation or the quadratic equation, doesn't matter which one. Obviously, a little bit easier, especially on this one, to plug it into the linear equation. So I did y equals 0 minus 2. When I plugged in 0, and that gives me y equals negative 2. So like we already knew from the graph, that one point of intersection is at 0, negative 2. And then if I plug in 4 for x, that'll give me y equals 2. And that other intersection is at 4, 2. Next problem. All right, again, the graph is given. You can see that the solutions here will be negative 1, 3. And at 3, negative 5. Okay. But we're going to solve it algebraically. So I'm going to take negative 2x plus 1 and substitute it in for y. And I have negative 2x plus 1 equals negative x squared plus 4. So this time, just slightly different. I'm going to take everything on the right side of the equation and move it to the left side so I get that x squared to be positive. Okay, just because I'm planning on factoring here. If we're doing quadratic formula, at the end of the day, it doesn't really matter, but it can be helpful to keep the leading coefficient positive. So I'm going to add x squared and subtract 4. Add x squared, subtract 4, and so I'll have x squared minus 2x minus 3 equals 0. So here I got a trinomial. There's no GCF, but it's looking like I can factor it. What are two factors of negative 3 that add to give me negative 2? Good. Negative 3 and 1. X minus 3 times x plus 1 equals 0. I'll set both factors equal to 0. So x minus 3 equals 0 gives me x equals 3. X plus 1 equals 0 gives me x equals negative 1. All right, so now we want to plug it back in. We want to plug the x's back in. Again, just like the previous, it's easier to plug it into the linear equation. So I'm going to do y equals negative 2 times 3 plus 1, which gives you y equals negative 6 plus 1, which y equals negative 5. So, like we already knew, that point of intersection is at 3, negative 5. And then I'm going to plug in negative 1. So that gives me negative 2 times negative 1 is 2, plus 1 gives me 3. So that other point of intersection is at negative 1, 3. All right, here, this one's a little different. There's only one point of intersection. It's hard to see. So I'm going to take 2x squared, substitute it in for y. And I have 2x squared equals negative 4x minus 2. So again, I want to keep the x squared positive, so I'm going to add 4x. Add 2, and I'll have 2x squared plus 4x plus 2 equals 0. So, what is my first step whenever I'm factoring? Greatest common factor. What would that be here? 2.
Why not 2x?
Because there's not an x on the third term. So that gives us 2 times x squared plus 2x plus 1 equals 0. So now I have a trinomial where a equals 1. So I only need 2 factors of 1 that add to give me 2. 1 and 1. So my factors will be 2 times x plus 1 times x plus 1 equals 0. So we want to set all the factors equal to 0. You don't need to set x plus 1 equal to 0 twice. Okay, you don't have to do that. And 2 equals 0 is just nothing. So, because that's exactly right. So, subtract 1, we get x equals negative 1. Right? So, again, it's only there's only intersection at one point here. So, makes sense, right? There's only one x. So, I'll take that, plug it in. Here, change it up a little bit, getting kind of crazy. I plugged it into the quadratic. 2 times negative 1 squared, because I'm cool like that. All right, negative 1 squared is 1, so y equals 2. So that point of intersection is at negative 1, 2. So here I'm going to take x minus 1, substitute it in for y. All right, because the 3x squared is positive on the right side, I'm going to move everything to the right side here. So I'm going to subtract x, and I'm going to add 1. So that gives me 3x squared minus x minus 4 equals 0. Yeah. So here, there's no GCF and a is greater than 1, so we do need to do the AC method. A times c gives me negative 12. What are 2 factors of negative 12 that add to give me negative 1?
3 and negative 4.
Good.
How do you know that so freaking quick? It's kind of easy. Nowadays.
All right, so I split the middle term, negative 4x and 3x. Remember that order doesn't matter. I bring down my negative 4, and I bring down my 3x squared. So now I have 4 terms. Uno, dos, tres, cuatro. All right, and so I'll factor by grouping. Group, 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 group. All right, so what's the GCF of that first group? X gives me 3x minus 4. What would be the GCF of my second group? 1. So my two factors are 3x minus 4 and x plus 1. So we're going to have some fun with fractions here. 3x minus 4 means x equals 4/3. Or 1 1/3.
How did you get x and 1?
And then x also equals -1. Now I want to take my x's and plug them back in. All right, the -1's easy, right? Plug it back in, you get -2. All right, well, the 3x squared minus 5. I'm going to do 4/3 minus 1.
Just 1/3. 1/3, right?
Yeah, it is 1/3. So that'll give me 4/3 minus 3/3 common denominator, which gives me 1/3. Okay. So my points of intersection are at 1/3, 1 1/3, and 1/3.
Where did the -2 come from?
You do the y equals -5.
All right, so next here, again, more fun with fractions. I'm going to substitute 1/2 x squared plus 4x minus 3. I'll have 1/2 x squared plus 4x minus 3 equals -x minus 10. So I want to take -x minus 10 and I want to move it to the left side of my equation. So I'm going to add x, which gives me 1/2 x squared plus 5x. And then I'm going to add 10, which gives me 7 equals 0. So the way this is looking made me, now this isn't the only way to do it. I decided to do quadratic formula.
Wait, can't you factor by a half?
Can't you factor by, so you could like multiply by 2 to get rid of the fraction.
And then you could square it.
And then that
Just do the easiest
should,
possible.
so I just did quadratic formula. Quadratic formula is -b, so that give me a -5 plus or minus the square root of b squared minus 4. A is 1/2. C is 7. All over 2a. Okay, go and get that set up.
We're gonna do seats.
So that gives me -5.
Still sitting next to the same person.
Shh. -5 plus or minus, like, all right, we have -5 plus or minus the square root of 25 minus 4 times 1/2 is 2 times 7 gives me 14. And then 2 times 1/2 is 1, right? So our denominator is just 1. So we'll have -5 plus or minus the square root of 11. So this is 2 x's. We have an x of -5. Let me see if I'm giving you the answer. -5 plus square root of 11 and x equals -5 minus square root of 11. All right, y'all do that in the calculator and get the decimals.
Do you want to surround it?
Yeah.
-0.7. -1.7.
Okay, yeah, -1.683. I did 3 decimals. Good, Caitlin. And then -5 minus the square root of 11.
-8.32.
Good. Negative 8.317. Good, good, good. You're on it, Caitlin. All right, so next part here, we're going to plug them in for x to get the y, right? So
What does it say? So, like,
I would plug it into the linear equation here. Katie, what's up?
I can't see what the X says.
Oh, negative 8.317. Okay. All right, so when we plug this back in, I'd plug it into the linear. So make sure where people make mistakes, that's a negative and then negative 1.683 minus 10. So you're really just doing you're really doing 1.683 minus 10 because a negative 1.683 is a positive 1.683. And then do y equals a negative 8.317 minus 10, which really makes that a positive 8.317.
It's the same thing, but it's
Nice, good, Caitlin. It's the same thing but switched. Nice work. All right, so obviously by the graph of the next one, there's no intersection, so it's no solution. And so if you're solving it algebraically, you would have an I. Okay. When I have the square root of negative 80, when you get to that point and you have an I, an imaginary solution, that would tell you algebraically that these two, the linear and quadratic equations here, are not going to intersect.
if you see a graph
No
like
solution.
Do I have to write
and
it?
it's like you have to solve it. Do you have to solve that algebraically?
So if I have
No solution. Huh?
if I have a negative square root, like a square root, it's negative, just stop.
Yes, you can say this is going to be no solution.
If it doesn't say solve algebraically, can I just put it in my calculator and see that it doesn't intersect and say no solution?
Yep.
Smart.
That's it.
All right, here's the answer to the first question on the assignment. Here's the answer to the second equation.
There's no solutions on the bottom line.
Yep. Yeah.
Here's the answers to the next two.
Yay, I'm actually doing something right.
I know, me too.
Yay!
Last two.
Oh, that's right.
You got it, Keely.
Whoa, that's a lot.
Is it okay if I did negative 2.5 instead of the 5 over 2?
Sure.
Wait, that's
I'm
the
just gonna pray those decimals.
Halves
That's
is-
fine.
Wait, is 19 halves the same as 9 and
Oh, we got it right.
Yes.
Oh,
Yay!
It is?
Yes.
Yes!